Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use yolov10.tf light format model, means we are going to create our own custom object detection model in .tf light format for yolov10, and then we are going to detect a car number plate, and then we are going to read a number plate. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to use yolov10.tf light format model. So if you don't know how to use yolov10.tf light format model with latest Raspberry Pi OS bookworm, I have already created the video. I will mention the link. You need to simply watch video, and then you will get the idea how to use yolov10.tf light format model for object detection on latest Raspberry Pi OS bookworm 64-bit version. So in this session we are going to basically detect a car number plate with the help of .tf light format model, and then we are going to read a number plate. So let's get started. So for this I have already done with package installation. As I mentioned, you need to simply watch the first basic video where I have already explained how to install all those packages for yolov10.tf light format project. So I have done with package installation. So for today's session I have created here a new repository rpi OCR number plate read. I will mention the link. You need to simply copy paste the link inside the web browser, then go to the code and click on download zip. It will download our zip format repository. As you can see, we have successfully downloaded our repository. Then just open file manager and go to the downloads, and then this is what our repository. Right click and then just click on extract. Here it will extract our repository as our folder. So this is what our folder. We are going to simply move our folder inside our main directory, which is home. So just right click, cut, click on home, and then paste the repository over here. Done. And then simply open a repository, or we can say simply open the folder. So let's just first watch our video. So nr.mp4, as you can see, this is what our video file. So open with VLC media player. And friends, as you can see, this is basically toll plaza, and here it is. We have all the cars. Simple. So our goal is to detect a car number plate. For that, of course, we are going to use yolov10.tf light format model, means we are going to create our own custom object detection model which detect the number plate. Simple. And then with the help of OCR, we are going to read a number plate. That's it. So this is what our video file. So let's get started. First we need images. So for that I have already trained images with the help of label img. So I have mentioned the link. So for that, simply download.txt, right click to the file and open with text editor. It will open the file as a text editor, and this is what our mega cloud link, where I have mentioned the .zip format file. Inside that we have all the trained images with the help of label img. So just copy the link, open browser and new tab, and just paste link, hit enter. It will open a mega cloud link. Okay friends, as you can see, freedom tech 1.zip. Just click on download and it will download our zip format folder. So friends, as you can see, we successfully download our zip format folder, freedom tech 1.zip. That's it, done. Now minimize all these things, close the file, text file, and go to the downloads where we have our freedom tech 1.zip. Just right click, cut, go to the home and our folder, our repository, and then just paste our zip format file. And here just change the name of the file, means just rename it. We are going to simply remove one, means we are going to rename the file as a freedomtech.zip. So right now the file is basically freedomtech1.zip. So just remove one and make it freedomtech.zip. Simple. Just click on OK. So we have done with our images. So inside this file we have all the images with their .txt format file. Simple. So now we are going to simply move our freedomtech.zip on our Google Drive. So here I have already opened a Google Drive. So now simply just click on new, and then it will open like this way. It will open the window like this way. Just click on file upload, and then go to the home, our repository, and freedomtech.zip. Click on open, and it will upload our freedomtech.zip on our Google Drive. So meanwhile I will open a Google Colab machine. So friends, as you can see, I have opened Google Colab. Now simply click on upload, click on browse, and then go to the home, our repository, and inside that I have mentioned .ipynb Google Colab file. So just select it, and now it will upload our Colab file on Google Colab machine. So friends, we successfully upload our Colab file. Now here just go to the runtime, change runtime type, and we are going to select Python 3 and select T4 GPU. Then just click on save, and then click on connect. So friends, we are successfully connected. Now we are going to simply run our cell one by one. So let's just click on first cell, then click on next cell. It will install Ultralytics on our Colab machine. So friends, we successfully install Ultralytics. Now just scroll down and just import the packages. Done. Now just again scroll down, and here we are going to check if our yolov10 is installed or not. So for that, simply we are going to use yolov10 and means the nano model. So as I mentioned, for TF Lite format we need nano model. So let's just first check if yolov10 install or not. So just click on next cell. It will download yolov10 n.pt model, and then it will use doc.jpeg image from RoboFlow, and then we have detection. So from this image we have detection basically, and it's saved inside runs, detect, and predict folder. So if you just click on this folder icon, and if you go here in runs, so this is what our runs folder, then we have detect folder, and inside that we have predict folder, and then we have our doc.jpeg image. If you open the image, and as you can see, there is a detection, dog and person. It means we successfully install yolov10 on our Google Colab machine. Also we have our yolov10 n.pt model. So now we are going to mount our Google Drive. So if I just go over here, and as you can see, freedomtech.zip one upload completed, means we successfully upload our .zip format freedomtech.zip on our Google Drive. So let's just mount our Google Drive. So just click on the next cell, then it will open this kind of window. Permit this notebook to access your Google Drive files. Just click on connect to Google Drive, and then you need to select your Google Drive, means you need to select the Gmail ID which you use as your Google Drive for saving freedomtech.zip. So just select the Gmail ID, then click on continue. Then just scroll down, click on again continue. That's it. Now it will mount our Google Drive on our Colab machine. So friends, we successfully mount our Google Drive on our Colab machine, and inside that we have our freedomtech.zip file. As you can see, this one, freedomtech.zip. Now let's just create a datasets folder, and inside that we are going to unzip our freedomtech.zip. So just click on next cell. Done. As you can see, it's unzipping our images and their .txt file. Done. Here it is, what our dataset folder. Inside that we have freedomtech folder, and inside that we have images and labels. So now here we are going to create a data.yaml file. So just go to the freedomtech, click on this three dot, and click on new file, and here mention the name data data.yaml and just hit enter. It will create a data.yaml empty file. Just double click on the file, it will open our file like this way. As you can see, this is what our data.yml file. Right now there is nothing, it is completely empty. So we are going to paste the code. So just open our repository again. This is what our repository, and inside that I have mentioned data.txt. Right click, text editor, and then this is what the code. Just copy it, copy as it is, copy, and data.yml, just press here Ctrl plus V. It will paste our code inside our data.yml file. Done. Now here names, so we are going to mention our class name. So our class name is basically number plate. So number plate, and then number of class, of course we have only one class, which is the number plate, so there is no need to change for number of class 1. And then now simply press Ctrl plus S. It will save our data.yml file. Just close the data.yml file. Done. Now just scroll down, and now we are going to start our training. So model yolov10 n.pt, data.yml file 100 epochs, and image size is basically 240 because we are going to use a yolov10 n. a light model, or we can say the nano model. So let's just start our training. So friends, as you can see, training is started. 1 out of 100, so it will take some time. Meanwhile I will pause video. So friends, we have completed our training process, and our model is basically saved inside runs, detect and train folder. So now here on the next cell I have mentioned our model. As you can see, we have our model inside runs, detect, train, waits, and base.pt, which is our model, custom object detection model, which we just created. And we are going to test our model with our image. As you can see, I have mentioned the image from images folder. From images folder I have mentioned the image, and the image name is basically number plate 0.jpg. So if I click on the cell, then as you can see, result is basically saved inside runs, detect and predict 2. So if you go here, runs, detect and the predict 2 folder, inside that we have our image. As you can see, if you just double click on the image, then here it is. As you can see, we have detection. It's detecting our number plate. So we successfully create our model which basically detect our object. Now we are going to convert our base.pt model into TF-Lite format. For that we have our next cell. So just click on the next cell. I have mentioned the model path already there. So it will convert our base.pt model into TF-Lite format model. So friends, we successfully convert our model into TF-Lite format. As you can see, our model is basically saved inside runs, detect, train, waits. There is a base save model folder, and inside that we have base float 32.tf-lite model. So just click on the runs, then we have detect folder, then we have train folder, inside that we have waits folder, and then we have base save model folder. And if you click here, then we have base float 32. This is what our model, as you can see. Just click on it, click on download, and it will download our model. So friends, we successfully download our model. So if you minimize all these things, then go to the downloads, and this is what our model. Simple. So let's just close our text file also. This is what our model. So we are going to simply move our model inside our repository. So right click, cut, go to the home, and this is what our repository means folder. Just paste the model over here. And then of course this is the custom object detection model. So we are going to create our custom label file also, which is coco1.txt. So right click, new file, coco1.txt, click on OK, and then just open the file as a text editor. And here we are going to mention our class name, which is number plate. Simple, number plate. File, click on save. We are ready. We have our model, we have our video, we have coco1.txt file. Now simply we are going to open our main file, which is number plate read.py. So right click and open with Tony Python IDE. So friends, as you can see, this is what our main file, where we have a basic object detection, yolov10, and we have our model. I have mentioned the model already there. Then we have coco1.txt, this is what our video file, and then we have our detection. Here it is, as you can see, we have detection, we have object detection, so x1, y1, x2, y2, then we have our class. This is the basic code, simple. So let's just first start our code, then I will explain all these things. But first let me mention here one thing, the number plate reading method which we are going to use here, which is a pedal OCR. This is the number plate, or we can say basically this is the method which we are going to use for reading the text from number plate. So pedal OCR. So for that, first we are going to install our packages. So if you open the repository, I have mentioned here install.txt file, just right click, text editor, open as a text editor, and then this is the two packages which we need. So just copy first package, copy it, and open Tony Python ID which we already opened. Then go to the tools, manage packages, and just paste the name which we copied from our install.txt file. So just press Ctrl+V. So this is the first package, as you can see, this is the first package which we need. So click on search on PyPy, it will search for this package. This is the first package, just select it, first package, and then just click on install. It will install our package on our Raspberry Pi Bookworm 64-bit version. So it will take some time, meanwhile I will pause video. So friends, we successfully install our pedal package, which is the first package. Now just open again text file, and this is what our next package, the second package, which is pedal OCR. So just copy as it is, copy it, and here just paste it, Ctrl+V, and this is the package. Now simply click on search on PyPy, it will search for the package, first package, select it, click on install. So friends, we install our second package also, pedal OCR. We have done. Now just close the tools, and now just close also our text file, simple. Now we are ready, and we are going to run our code, and then I will explain the code. So when we start our code, it will download the model which require for pedal OCR. So friends, as you can see, as I mentioned, it will download required model for pedal OCR. So here it is, it's downloading the models for pedal OCR. Done. Now it will start our frame. So friends, as you can see, it started our frame. There is our object detection, means we create our own model which detect our number plate, and then with the help of pedal OCR, it's reading the text from number. As you can see, HR26BS3982, HR26BS3982. That's it. Now I will explain the full code, how basically pedal OCR work also. So here friends, as you can see, from pedal OCR, our package pedal OCR, we are going to import pedal OCR. This is how we want to import the package pedal OCR. From pedal OCR, import pedal OCR. Done. And then OCR is just a variable. So OCR is equal to this pedal OCR. Simple. Now we are going to call a OCR. So I have created here a function. So perform OCR, this is the function name, and of course our object is our frame, means image array. We are going to use array format frame. So image array is our object. So if there is no image, means if image array is none, then it will raise the error. So raise value error, image is none. Simple. Then results is again just a variable. So results is now our OCR, this OCR.OCR, and inside that, of course, we are going to pass our object. So our object is basically image array, and then because we want to recognize the text from our detected number plate, so here we want to enable the recognition of the text. So rec is equal to true. So rec is equal to true is basically enables the text recognition, as simple as. And then we are going to print the results for our knowing purpose, what basically we have inside the results. So let's just start our code. So here it is, as you can see, print results, and it's printing the results, means we are passing our object, so we are passing basically image in. So when we have our object detection, here it is, as you can see, when we have our object detection, so here as I mentioned, we mention basically the condition. So if I open the frame, so what is our condition? As you can see, basically our number plate is detected from over here, but I just want to detect my number plate over here in this area. So for that I have mentioned the area, and because I have commented here, I have commented here cv2.polyline function, that's why there is no polyline, but basically I have mentioned the area. So if I save the code and if I run the code again, so friends, as you can see, now again I have started the frame, and because I have uncommented the cv2.polylines function, it's now highlighting our region of interest area. So this is what my region of interest area means. If my object, if it is inside this area, then only I just want to detect the object, I just want to use my pedal OCR. So here I have create a polyline. So with the help of this function, as you can see, if I move my cursor on the frame, inside here it's basically showing x and y coordinates. So if I want to draw the polyline, I need a coordinates. So if I just go here it is, as you can see, it say that x value is basically 124 and y value is basically 342. So this is how I have mentioned here these values. If I just go here, I will get xy value. If I just go here, I will get xy value. If I just go over here, I will get again xy value, here xy value, and this is how I have mentioned all these values. So for drawing polyline, we need 1 2 3 4 value, 4 xy coordinates, and then with the help of cv2.polylines, here np.array, this is the area, np.in32 true, and this is the color of polyline, and this is the thickness. This is how we can draw the polylines. Basic, simple. So this is how I have mentioned my region of interest area, ROI. So when we have our object center point, so here it is, as you can see, how do we get our center point? Simple, we have rectangle coordinates, so with the help of rectangle coordinates we will get our center point. So cx is basically int this x1 plus x2 divided by 2, we will get our cx, and the cy is basically int y1 plus y2 divided by 2, we will get our cy. And then this is what our cx and cy is basically our rectangle, our object detected rectangle center point. Simple. So here when this is what our object, and this is what our object detected rectangle, blue color rectangle. So cx and cy is basically the center point of the rectangle. So if I mention here for our knowing purpose, if I go here and if I mention here cv2.circle method, cv2.circle, I just want to draw a circle on frame, and the coordinates, which is our center point, which is cx and cy, then the radius 4, and let's just mention color red 00255, and because I just want to fill my circle, so -1. So I have just mentioned cv2.circle method for our knowing purpose. So this is the new code line, so I just want to save the code, and if I start again a code, so friends, as you can see, there is a center point in red color. So this is what my center point of my object means, the rectangle. Rectangle is basically our detected object. So if this red color center point, if it is inside my area, then only we have detection. For that we have function which is cv2.pointPolygon_test. So for cv2.pointPolygon_test, we need our area and then we need center point. So how do we mention our area? So for our area is basically this np.array. So just copy as it is and mention over here. Here it is, as you can see, I have just mentioned as it is. Just copy np array to np int32, copy as it is, and then as I mentioned, center point. So what is our center point? Our center point is basically cx and cy in tuple format and then the false. And for cv2.pointPolygon_test, if the center point, if it is inside the rectangle or if it is inside our polylines, we have 1. We have 1. So if the result if greater than or is equal to 0, then only we are going to do all these things, means drawing the rectangle, then we are going to use our pedal OCR for detecting the text. Simple. For that if you start the while loop, the detection is only performed inside our polyline area. Simple. So this is how the function, this is how basically our condition work, not function, basically our condition work. Our condition is what? I just want to detect my object if my object center point, if it is inside my mention area. Simple. So now when we detected our object, then we are going to use our perform OCR function. So here, as you can see, I have called my perform OCR function over here. Our function name is perform OCR, and then inside that we are going to pass our crop image, which is our rectangle. So crop is equal to frame y1 colon y2 x1 colon x2. This is how we crop our image. So crop is equal to this, and then we are going to resize our crop. So 110 is the width and 30 is the height, and then this crop image we are going to pass inside our perform OCR function here, okay, and then it will return the results. So what we have inside the results? So inside results we have rectangle. As you can see, this is the rectangle, and this is the number plate. As you can see, this is the text. If I open the frame, HR26 B3982, this is the text which we detect with the help of our yolov10. Means we draw the rectangle and we mention our condition with the help of polylines, we mention our ROI, and then with the help of PADL OCR we are reading the text. So this is what our text, as you can see. Simple. So this is basically the results. So I don't want all these things from the results, I just want my text. So this is basically 0. This is basically starting line. So I have mentioned here a 0. Means we always mention this as a 0. Simple. So results 0. If it is no results, so if result 0 is not none, then for result from this results, for results in results. Simple. This is the basic code. This is how we use for loop. Simple. So for result in this results, then 0. So here I just want this, I just want my text. So this is basically 0 and this is basically 1. Simple. This is a 0 and this is 1. So here it is, as you can see, from result I want 1. So this result will print all this line, and then from this line I just want this line. So this is the 0 and then we have comma. So this is 0 and this is 1. So from this 1, so if I print result and then 1, it will only print this line. It will only print this line. So if I save the code and if I start again the code, so friends, as you can see, now it's printing only this line. Only this line. This is the 1, because we mention here print from result. I just want to print my one line, first line. So this is, as I mentioned, this is 0 and then this is 1. So print result 1. So it's only printing the text file, text name which we detected, and then another text. So from this I just want this text which is my number plate. So here I have mentioned the 0. So print result 1, it's printing this, and then from this 1 I just want this first line. So first is basically 0. So if I mention here 0, now it will print only this text which is our number plate text. Simple. So if I save the code, if I run the code, so friends, as you can see, now it's printing only our text. Now I hope you all clear why we have our result with this 1 and 0. Simple. I hope you all clear. Now it's only printing the text. There is no comma and all other things. Why? Because we mention here this function, as you can see, the join method. This join will basically join all detected text into single string. That's why we mention here dot join. That's it. And then we are going to append all the text inside the detected, this detected text as a list. So detected text dot append, we are going to pass our text, this text. this text we are going to pass inside this detected text. That's it. And then we are going to return with join method, we are going to return this detected text. So if you go here and where we have our text and we are basically calling our function, and inside that we are going to pass our image which is the crop. And if you print here a text, so let me comment here print, so here this one, and now it will print our final text. So let me start again code. So friends, our frame is started and we are printing our final result here. This is how we call our function. Inside that we pass our crop and then we are printing this text. So here it is, as you can see, this is what our final result, our number plate text. That's it. And then we are going to put the text with the help of series on put text rect method. We are going to put the text on cx and cy where we have our center point. So for mentioning our number plate text, I have adjust the coordinates, so cx minus 50 and cy minus 30, and then we will get this kind of result. We have our number plate text, detected text over here, as you can see. Simple. So this is how our full code work. We create our own model. So we have our detection, we are detecting our number plate. Then we install paddle OCR. With the help of paddle OCR, we are basically reading the text. I have explained the function. This is what our function, simple. And then we have our result. We mention our area with the help of polylines. We mention our area. Then we have our condition. So what is our condition? Our condition is basically this ct2.point polygon test method. So if our center point, if it is inside our area, means if it is inside our polyline, then only we have detection, then only we are going to call our paddle OCR function, perform OCR, and then inside that we are going to pass our crop image, and then we have our result. Simple. So this is how our full code will work. Now we are going to simply start our while loop. So let me stop the code, and here I will mention 1, it will start our while loop. Friends, as you can see, I have started a while loop, and then we have here a detection also. When the car cross our area, there is no detection, there is nothing, as you can see. Now the car number plate, if it is inside our area, then we have detection, and then we have number, as you can see, DL1C8337. Simple. Now let's just, what we are going to do, we will hide all these things. We will hide our detected object rectangle, also we will hide our polyline area. Simple. So let's just comment all these things. So here this is what our rectangle method. So comment it. There is no need to circle now, and then we are going to only put the detected number text on our number plate, and then there is no need of area also. Simple. So we hide all these things. Now we have our result. So friends, as you can see, now there is no polyline, there is nothing, because we hide all these things. Now this is what our final result. We have number plate and their text on the number plate also. So watch for this car. When this car, if it is inside our area, then only we have detection. So DL1CH8337, DL1CH8337. As you can see, it's detecting our number plate. Now this car passed, then we have next car. When the car number plate, if it is inside our area, we have detection, and as you can see, there is a detection HR0IAD3205, HROIAD3205. For this number plate, as you can see, this is what our detection. So friends, this is how you can use yolov10, and you can use paddle OCR for reading the number plate, and then you will have this kind of result. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.